Okay, this is Math 2. We're going to do 66 to 69 in this video, and then 70 to 73 in the next video. Or if we run out of time, then obviously I'll just do whatever we have left in the other video. Okay, the first one, we have triangle, or not triangle, circle A at the right. Measure of angle C, 64 degrees. What is the rest of these guys down here? So I made this a little bigger because it's just easier to write on. So if you haven't actually copied down this picture, please do so. So pause the video and actually take a few minutes and actually draw this diagram out on your paper and make it about 3 fingers tall or so, maybe even 4. And then put everything through. So it says the measure of angle C is 64 degrees. So if you're looking here, that would be BCF. I'm assuming it's this angle right in here, 64 degrees. Okay, and then from there, we basically have to work our way around the circle. So I'm going to do this in black because we know this is not going to change. Okay, so angle D is over here. Okay, now from the 64 degrees, we can actually just make our way through the entire circle. So I'm just going to work on the circle, and then you can fill in A through F on your own based on what it is that I'm doing. So let's see, BCF, right, is this arc, is this angle right here, which makes it part of this arc. And since, let's see, it would be... Actually, I need yellow. Yellow would be better. That would be this one right here, just like that, right? And so if this is not in the middle, right, because that would make it at angle A, or it would be the central angle, but it's not. It's the inscribed angle, which means that B to F is going to be double your inscribed angle. So that makes it, let's see, double 64 would be 128 out here, right? And then, so that would be 128. And then since this arc here also has this angle, that is a part of it. So I'm going to cover that up so you can see a little bit better. So this angle here also subtends the same arc right here. That means this is going to be 64 also, because they both intercept the same arc. And then you can just as easily say the same thing about this angle here. Since this arc belongs to that angle down in there, and that is definitely still not a central angle, this is 64 degrees also. Okay, so you have 64, 64, 64. And then, let's see, are we missing anything else? This central angle here, angle A, belongs to the same arc, but it is a central angle now, not an inscribed angle. So that makes it 128, because it's the same, the central angle is going to be the same as the intercepted arc. And then, are we missing anything else? Oh, I guess we can fill in this part too. So this angle here is on a line right here. So if you take away 180 minus 128, oh, sneeze. 20 minus 128, what is it? 52. So this is 52 degrees right in here, because this is makes 180. And then if this is 52 degrees, which is a central angle, then that means let's see, we could do like this one right here, this one right there would be 52 degrees also, because that one's 52 degrees. It's a central angle. And then, let's see, do we have anything else to go for? No, that's pretty much it. Oh, we can do... Can we do the rest of these? I don't even know. I'm trying to think what other pieces we have available that we can use. I really would like to know what C to D is, but I guess we can't really figure that out until we figure that one out. And I'm not really interested in doing that one right now. D to E. To D to E, we'd know if we knew this angle up here. But that one's a little tricky too. I think we're good. Yeah, I think we're good. Alright, I'm moving on. Yeah, fill in the rest of these, look at what they're saying, and then pick out the pieces. You should be able to handle the rest of it. Oh, C to F is 180. I do know that much. Is there anything else after that? No, that's about it. Okay. All right, 67. A, B, C, D, E is a regular pentagon inscribed in circle O. Okay, so I actually drew a picture because it actually does help to, because it does say, meaning that each of the 5 vertices lie on the circle. Inscribed inside means it's going to be inside. I could have easily drawn the pentagon outside the circle and actually have the circle inside of it, or somewhat in, and then that would have completely done a different, it would have definitely have been a different situation. So draw a diagram of A, B, C, D, E and circle O on your paper, which you should because that's part of the question. And then what I'm going to do, because it always seems to fall this way, they typically usually want you to put the radius. So I'm going to put the radii on here. And then we're going to have to answer the question. So the first thing says, what is the measure of angle EDC? That's not helpful. Okay. I guess we got to label these. So let's go with, this is A, this is point A, this is point B, this is point C, this is point D. Call this point E. A, B, C, D, E. What is the measure of angle EDC? Where's EDC? Okay, so we just want to know one angle. Okay, well, that's fine. So what is this? 5-sided regular figure. So 5 minus 2, right? 5 minus 2 times 180. So 3 times 180 is 540. 540, let's see, 540 divided by 5. What's 540 divided by 5? 108, right? No, that's not right. Yeah, no, it might be right. I can never remember that. Yeah, 108. All right, so this is 108 degrees because, well, they're all the same. They're all 108s. 108, 108, 108, 108. Okay. And then, how did you determine your answer? Well, it's a regular pentagon, so if you use some of the interior angles theorem, and then just divide by 5 because each one has to be the same. There you go. What is the relationship of BOC? Okay, O is in the middle, by the way, so that's in the middle. BO to C. Oh, this angle in here. Oh, that should be easy to do. So if the radius is coming through, it's going to cut each angle in half. So that would be, let's see, what's half of 108 divided by 2? 54, 54. Okay, so this is 54 degrees. This is 54 degrees. So BOC is 54. That's 54. So that this triangle right here would be like this triangle right here. 54, 54, and then whatever's left over. Okay, you can figure that one out yourself. What relationship did you use? I don't know what it means by that. What do you mean, what relationship? A triangle makes 180. That's the triangle sum theorem, I'm assuming. Okay, and then what is the measure of arc EBC? Arc E to B to C. Okay, so here's exactly what we're talking about. So it's got 3 letters, so it has to be a major arc, right? Major arc. So it has to be more than 180 degrees. So that means you can't go across. You're definitely not going through the triangle, that's for sure. I mean, through the through the diagram or through the circle or through the pentagon, but so we have to go around it. So EBC is really from E all the way to B and then all the way down to C, like this. Okay, well that should be pretty easy to find. This angle here is 108. So technically, this is an inscribed angle down here for this arc. So this angle here is the inscribed angle, and this is your intercepted arc. So since your inscribed angle is 108, your intercepted arc is going to be double 108. So from E to B to C should be double 108. So 108 times 2 is going to be 216 degrees. So from E all the way to B to C it is 216 degrees. All right, 68. Describe each. Show more than one way to calculate this measure. I'm happy if you just know one way to calculate the measure. So there you go. I'm sure you can figure out a different way to do it, but right now just to learn one way really well. Describe each circle by stating the center and the radius. Complete the square and rewrite the equation in graphing form. Describe the circle by stating the radius. Okay, so center. What is the center? The center is at... I'm going to rewrite this really quick. So x plus 5 squared plus y minus 0 squared equals 10, right? So the center is at negative 5 and 0. Okay. And then your radius, since 10 is not a very nice number, like 36 or 16 or 25 or 49 or 81 or 100 for that matter, then realistically I'm just going to leave the radius as square root of 10, or better known as 10 root, somewhere around 3.16, yeah, or somewhere around 3.16. So that's A. And then B, you have to complete the square. So I guess we can call it the purple one. We'll do this. We'll do these in purple, right? So we have y squared, and we have negative 1y, negative 1y, negative 1. And then we have the blue. We have x squared minus 3x minus 3x, because we're cut the negative 6x in half. 3x minus 3. Okay, so we need a 9. So we need a 9, and we need a positive 1. Okay, so that makes 10 altogether, which gives us, what do we need to add? So negative 5 plus what is going to give us positive 10? And that would be positive 15 on both sides, because that'll give us a positive 10 as a result, right? So positive 15 on that side. So then we have x minus 3 squared plus, what is this? Plus, oh, sorry, I got lost track. Squared. So your center is at, what is this at? So you can write this in, and then what's your radius? You can write that in yourself. Okay, and then last one, 69. Okay, I don't think there's anything interesting in 69. So solve the equations below. Everything should be pretty straightforward. For part C, you might have to either do some factoring. I don't think you're going to be able to factor this. Do some... No, wait, I think this factors. Yes, this factors very nicely, actually. Ooh, this is a nice one. I think I want to do this one. What does this factor into? Two numbers multiply out to negative 33, but added together give you an 8. Aha, 11 and 3. So negative 11, no, positive 11 and negative 3. Yep, that gives you 8. So this is a really nice factoring situation here. Negative 33 at the top. We have 11, negative 3, and then you can figure out the rest of it, and you should get two answers for x. X equals, or x equals D should be pretty okay for the function f of x. Okay. Ooh, should we do 70? No, we'll stop. I'll do 70 in the other one. Okay. There it is.